Okay, so we're approaching the end of the theory side of pneumatics. So we've still got the maths part to do, but this is the kind of end of the theory stuff now. The last bit, as you can see on the screen, we've got automatic circuits. So this is circuits that operate without necessarily any human input, right? And it doesn't involve adding anything more than we've already done. It's just physical placement that matters now. And this is where you see why we have these different actuators and kind of maybe less common actuators, right? So consider this system that I've kind of laid out here. We've got a double acting cylinder, A, it's supposed to be an A, and it's connected to this 5-2 valve, alright? And the 5-2 valve is a pilot. And we've got two different 3-2 valves here, a roller trip spring return 3-2 as valve 1, and a plunger spring return 3-2 as valve 2. And you can see how we've positioned them. We've positioned them in such a way that the cylinder will actuate the valves as it goes in and out. So as cylinder A outstrokes, when it outstrokes, it'll actuate valve 2. When it instrokes, it'll actuate valve 1. If we use these two valves to control the cylinder, then the system will run automatically without us doing anything. So if we make valve 2, so when it outstrokes, it strikes valve 2, if we make valve 2 instroke this thing, so that's this port, that's the instroke port, so that's this side. So if I connect valve 2, we use a dotted line because this isn't main air, this is valve to valve, remember, right? So if valve 2 instrokes it, that must mean that valve 1 will outstroke it. I'm just going to change colour, otherwise it might get a wee bit on the confusing side. There you go. So when cylinder A outstrokes, it actuates valve 2. Valve 2 pilots, let's give that a name, valve 3. Valve 2 pilots valve 3, which instrokes cylinder A. When cylinder A instrokes, it actuates valve 1, which pilots valve 3, which outstrokes cylinder A. And the cycle continues. So basically, as soon as you provide a main air signal, consider there's main air to the 5-2, main air to the 3-2, main air to the 3-2. They're all the same signal. As soon as you turn main air on, this thing's just going to start instroking and outstroking at full speed. It's actually really fast. When we build these in school, it's surprisingly aggressive, violent almost. So that's an automatic circuit. Now bear in mind, we've already covered logic control and we've already covered object sensing and speed control and time delay. Those things can all be built into these automatic circuits, right? So for instance, I could turn this into a semi-automatic system. Let's take all of that, right, and really easily let's turn this into a semi-automatic. So Control C, go in a new page, and let's call it semi-automatic circuit. So this is where the user would have to do something maybe to get it going, or there's some other input. It won't just run automatically. So I could just use logic control. I could interrupt that main air symbol there. Oh, I don't know if I'm going to be able to do it without taking anything else out. Yeah, I could bring that out and that could be the output from a lever valve or something. Nope, what am I doing? Let's get me in here. So the user flicks the lever on valve 4. So basically, when you provide the main air to this system, what could very well happen, obviously depending on the last state of the 5-2 valve, cylinder A could outstroke immediately, actuate valve 2, but that won't instroke. It won't pilot valve 3 to instroke valve A, because there's no main air getting to this valve. We've interrupted the main air signal to this valve by using a lever. So the system won't actually start running automatically unless the user flicks that lever, at which point valve 2's got a main air signal to it, and then the system would work. So that's automatic and semi-automatic. Now it's quite common, let me just draw a bigger circuit here, alright. It's quite often to see circuits like this where there's seemingly two independent systems, but it's still an automatic circuit or a semi-automatic circuit. And what we're going to do is we're going to use the valves that surround cylinder A to control cylinder B, and the valves that are actuated by cylinder B to control the state of cylinder A. So, and the way they phrase these is, you should remember this, that as much as we can talk about cylinder A being in-stroked or out-stroked, we can also talk about it being positive or negative, where positive is out-stroked and negative is in-stroked. So we could have something that looked like, we could have a sequence that's written down that looks like that. A plus B plus A minus B minus, so that's saying A outstrokes, then B outstrokes, then A instrokes, then B instrokes. So like, you know, that's one way of describing these more complex actions in a pneumatic circuit. But again, there's nothing there new, we've already talked about positive and negative. So if when A outstrokes, the next thing happens is B outstrokes. So that means we want valve 1 to outstroke cylinder B. Yeah, because valve 1 is the one that's going to get struck when A outstrokes. So we're going to connect that to that. I think, and again, I'll use different colours. Got a dotted line in here, right? Okay. So from there to there, and from there to there. There you go. So when A outstrokes, B will be outstroked. When B outstrokes, so that we've got B plus, that'll hit valve 2. We want valve 2 to do the next one in the sequence, which is in-stroke A. So this guy must in-stroke valve A. Let's pick a different colour. This guy must in-stroke this guy. Nice one. So now we've got A in-stroke, and when A in-strokes, it'll actuate valve 3. And the next thing that happens is that B instrokes, so valve 3 must in-stroke, so valve 3's got to go all the way over to here, right? Blue. So valve 3's going to here. Oh, easy tiger, that's a mistake. It's going here. There you go. And then that only leaves one pair left. That only leaves this guy, and that must be, so this is in-stroking B. When B in-strokes, it's going to strike, it's going to actuate valve 4. And valve 4 must do the next one in the sequence, which is outstroke A. So valve 4 must be connected to this guy over here. Last colour. How's that? So that's a very kind of common, or that's kind of like the gold standard of automatic or semi-automatic. So this one's automatic, obviously. Automatic. You could make that semi-automatic by breaking any one of those main, you know, the main 81 or the main 83, the main 84, even the main 85 you could break that with a symbol, and that would prevent this system from automatically running. And again, the problem could say the problem could say A has to outstroke slowly. So that's speed control for A. So that's these two hoses. It's to outstroke slowly. So that's a unidirectional flow restrictor on that one, on the in-stroke port, on the in-stroke hose. Or you could say that after B outstrokes, that's B plus, A is going to in-stroke, but it's not to in-stroke straight away, it's to in-stroke after 3 seconds. So that means that you need a time delay in between this valve and this pilot on this valve too. So you would need a time delay components in here, unidirectional flow restrictor pointing at a reservoir. And then I've already talked about using and control and or control. So there's all sorts of different things you can put in place on these automatic circuits. What I'm going to do now is ask a question, right? And I'm going to ask 2 questions. One is going to be to design an automatic circuit, and frankly, you're already looking at the answer, alright? And basically just, it's a question that essentially asks you to copy this bit out. And then I'll give you a circuit, a second question where I'll give you a circuit and ask you to explain its operation. And in that second circuit, it's going to have everything. And in the explanation of operation, I'm looking for a parts list first, obviously, and then I'm looking for an explanation of operation where you use cylinder A, valve 2, valve 3, that kind of terminology, but I also expect to see you putting things in order, perhaps identifying this, or definitely identifying the sequence, and using terms like when cylinder A outstrokes, it actuates valve 1 pilots valve 3 outstrokes cylinder B. That's the type of language that I'm looking for in your explanation of operation. But again, it'll have time delay, and it'll have speed control, and it'll have and control, and it'll have or control, and it'll have an air bleed in it, right? And I'll try to sample through all the different actuators. So, first question, I'm essentially asking you to redraw this. Second question, I'm asking you to explain the operation, but I'm drawing on every part of the theory of pneumatics so far, and that'll be the last question in the theory stuff. Now let me make these questions up. Give me a second. Right, so there's the two questions. That one's just the same as the one I've just spoke about, and then there's a circuit I've made up that's got pretty much everything in it. There's speed control, there's time delay, there's object sensing, there's OR control, there's AND control. It's an automatics, it's a semi-automatic circuit. I don't think it doesn't have as a single acting cylinder, I think. So there are actuators missing, obviously. I haven't used every single actuator, but used a good spread of them. Right, okay, so that'll be the end of the theory work. Thank you very much. Got the maths work to do next, which is short and sweet.